Okay, number 11, we skipped over 10, is similar to number 9. We have the cube root of 128. And this problem just wants you to practice on simplifying a radical. So, I don't believe 128 is a perfect cube. So, because I know 5 cubed is 125, and then 6 cubed is 216, I believe. I have to memorize them at one point. And this is in between those two. So what we're going to do is divide 128 down in primes and look for triplets, because we have a cube out here. So every time I get 3 of a number, they combine to be 1 and move out. They get to break out of jail, so to say. So this is even. I'm going to divide it by 2. So we'll say 2 and 64. Okay. 2 is prime, so I'm going to leave it alone. 64, I know that's a cube, so I'm just going to say 4 times 16. You can do it by 2. It'll still work out. 4 times 16, sorry. And then 16 can be broken down to 4 times 4. Okay, so I got 3 4s. 4 times 4 times 4 is 64, and then times 2. So these 3 4s combine, and they get to break out of jail. Okay, so that means I get to pull the 4 out. And then what's left is this 2. He didn't have a buddy. He was by himself. So the 2 will stay under the cube root. Okay, so this is how you simplify a radical. Now, if you broke this down the long way, let me go through everything. Let's say we did 128, and I divided by 2 in 64. And then I did 64, I divided by 2 and 32. And then I divide this by 2 and 16 because it's even. So if it's even, you can always divide by 2. So look, we got 3 2s. I get to bring a 2 out. But I'm still breaking down 16. 16 I can break down to 2 and 8. And then 8 will break down into 2 and 4. And 4 will break down to be 2 and 2. So look, we got 1, 2, 3 more 2s here. So I get to bring out another 2. If you bring out multiple numbers, you just multiply them together. So I had 3 2s here, had 3 more 2s here, and I still got this one solo 2 by itself. Okay, so I brought out 2 groups of 2s. There was 3 of them, bring them both out. So 2 times 2 is 4. That's how I got that. And then this 2 that's left stays underneath the cube root. So 4 cube root of 2. Let me simplify this. Uh-oh, I lost it. 4, 2 underneath, and make sure you go back and put the 3 there. Sometimes you'll forget that and you'll count it wrong, so be careful in Certify, because if you do that in Certify, it's going to give you a total new problem to work instead of accepting a strike. So take your time. And then number 12, we just want to find the cube root and simplify these two. So it's going to be the same process, but I'll go ahead and do that one as well. Number 12, we have the cube root of 32 divided by the cube root of 20, and we will see if these will reduce. Now, there are a couple of things you can do here. We can try to break it down to primes. I'll work it out 2 ways, or we can just try to reduce it. Since they are both under cube root, let me just show you what that looks like. This looks like this, cube root. And we'll just see if we get the same thing before I jump to conclusions and say this is equal. This is the same thing as putting it over one big cube root. Since this is a fraction, I'm going to try to reduce. Both of these numbers are divisible by 2. So if I divide, let me see. Matter of fact, they're both divisible by 4. That's the bigger number. So I'm going to divide both of these by 4. When I divide them by 4, I get the cube root. 32 divided by 4 is 8. And cube root, well, 20 divided by 4 is 5. Okay? So this is what I get. But mind you, we still have that issue with math don't like to have a radical on the bottom. Okay? So what this is really, what I'm really looking at, this is cube root of 8, which is 2. I can actually get a number there. And cube root of 5. Okay. 5 has an exponent of 1, How do I get rid of this cube root on the bottom if I only have one of them and I need 3? How many more do I need? I need 2 more. So I can either say 5 squared or I can say 25. Doesn't matter. I'm going to say cube root of 5 squared. Cube root of 5 squared. Whatever you do to the bottom, you got to do to the top. So I'm going to go ahead and evaluate this. Cube root of 8 is 2. And then we're going to say cube root, and we'll evaluate that as 25. And then on the bottom, this becomes cube root of 5 cubed, and that cube root and cube will cancel each other out. Okay, so at the end of the day, we are looking at 2 cube root of 25 divided by 5. So this should be our answer here. If you did it any other way, I think it will come out to be the same. But I'm going to let that one rest for now. So fraction bar 2, I need a cube root on the top. So put a 3 here, 25 underneath, and then a 5 on the bottom. So that'll get us through 148.